All right. So in this section, we're going to be talking about scale and angular misclosure calculation in land surveying. Our first question says that if a map has a scale of 1 is to 50,000 and the distance between the scale on the map is 4 centimeters, what is the actual distance between the 2 points? But first of all, we have to note that a scale is the ratio of map distance to ground distance. All right. Anytime we are being given the question like this, we have to try and put down our given. We have to try and put down our given. And we say that the given is the situation whereby we bring out the key point from our question so that we know the one we are supposed to find. Okay. So our question says that if a map has a scale of what? 1 is to 50,000. So first of all, let's put that down. The scale, our scale become equal to 1 is to 50,000. Good. And the distance between 2 points on the map is 4 centimeters. So it means that we can call this our map distance. Map distance. And our map distance, they say is equal to 4 centimeters. So our map distance can also be denoted as what? MD, which is equal to 4 centimeters. 4 centimeters. Good. From there, what is the actual distance between the 2 points? The actual distance between the 2 points can also be known as the what? The ground distance. So the actual distance is what? They don't know, they're asking us to find for. The actual distance. Actual distance. So before we can be able to find for the scale, we have to try and put down the formula. And that is what is going to help us to be able to solve for the work. Yes, that is going to help, is what is going to help us to be able to evaluate the work. Okay, so let's say this is our actual distance. We don't know. Okay, which is something that we don't know. Good. So from here, we just move to our solution. And then in the solution is where we are going to apply the formula and see how we can apply some various techniques to be able to make life much more easier. So we come to solution. In our solution, first of all, we said that the scale is equal to what? Map distance all over ground distance. So let's quickly write that down and see what we can discover from that. So we said the scale is equal to, or better still, let's call it the map scale. The map scale is equal to ground distance, or let me say map distance, the map distance. Okay, yes, map distance all over the actual distance, all over the actual distance. But here in this case, we can also say that um, the actual distance in some cases can also be denoted as the ground distance. Okay, so don't get confused. Don't get confused with that at all. So from algebraic expression, or if I want to use algebra, I can say that what my map scale is equal to what MD over what? AD. Okay, good. AD. Where what? MD is measured in what? Either or what? CM. Yes. So those are some of the tricks or techniques that you can be able to use to discover what the question is trying to tell you. Okay. So this is either going to be in what? CM or what? MM. So once you see that, you know that that is your map distance. Yes. And if you see km or meters, that becomes your actual distance. Yes. That will become your actual distance. That will become your actual distance. That will become your actual distance. All right. So let's, as simple as that, let's quickly put this down in our notebooks. And then so that as we proceed, we can be able to refer to make life easier. Okay. As easy as that. Okay. So this could either be in the map distance. If in the question is would that be in what? CM, centimeters or what? Millimeters. Whereby the actual distance or the ground distance in the question may either be given in what? KM or meters. So once you see that, you should be able to use that to be able to find your way. Okay, so now let's move back to our question again. The question they gave us, they say if a map has a scale of 1 is to what? 50,000. And as if you see a ratio like this, a ratio like this is the same as what? 1 over 50,000. Okay. So please don't get confused by that too. 1 over 50,000. So a scale and a fraction are equivalent. Okay. So um if a map has a scale of 1 is to 50,000 and the distance between 2 points on the map is 4 centimeters, what is the actual distance between the 2 points? So it means that it's the ground distance or the actual distance that they're asking us to find. So we just have to substitute whatever we have into the formula and to be able to eh, make life easier. Okay. So our scale that was given to us was what? 1 is to what? 50,000. So we put that over here. 1 is to 50,000. All is equal to the value that was given to us was in centimeters. So it should even tell us that that is the map distance. Okay. And that was just 4 centimeters, as we can all see from here. So let me quickly put that down. 4 centimeters. Good. So now we are supposed to find for what? Our actual distance. But the actual distance too is not given. So we don't know. Okay. From the idea of cross multiplication, we have to be able to use that concept to be able to make actual distance the subject and find for it. Okay, so we are going to do cross multiplication from here. Once you get here, we have to do a cross multiplication. Yes, the 4 centimeters will come and multiply the what? 50,000. Then the actual distance will go and multiply the one. But take note that the actual distance is measured in what? Kilometers or meters. So even after getting your answer, you have to either decide to come and convert it into what? Kilometers or meters. As simple as that. So from here, we can now say that um, our AD will multiply 1, our actual distance. So our actual distance times what? 1 is equal to 4 centimeters times 50,000. Okay, times 50,000. So from here, let's all pick our calculators and evaluate the relation and evaluate the relation. So 4 times 50,000 and 4 times 50,000 will give us 200,000. Okay, it's going to give us 200,000, 200,000 what? Centimeters. Okay, but actual distance is measured in what? Kilometers or meters. Okay, so we have to convert this, our answer, into what? Either kilometers or meters. Yes. So you can see me, I'm coming to right over here. But actual distance, okay, is measured, at actual distance is measured in what? Kilometers or meters. Okay. Hence, let's convert our answer into what? Hence, let's convert our answer into meters. Okay. Hence, let's convert our answer into meters. Okay. Yes. So, hence, let's convert our answer into meters. Hence, let's convert into meters. Good. Hence, let's convert into meters. So, from this concept we have just derived, we have to convert our what? 200,000 into meters. We have to convert our 200,000 into meters. But before then, how we have to find out that how many centimeters make 1 meter. Okay. And the answer is that 100 centimeters. From what we learned last semester, we realized that 100 centimeter is equal to what? 1 meter. Okay. Yes. 100 centimeter is equal to what? 1 meter. So we said that if if what? If 100 centimeters is equal to 1 meter, then if 100 centimeter is equal to what? 1 meter, then 200 centimeters is equal to x. Okay. Then 200,000 centimeters is equal to what? X. So we use the concept of cross multiplication to find for the value of what? Yes, to find for the value of x. We use the concept of cross multiplication to find for the value of x. X is going to multiply 100 and 1 will come and multiply this. But from the idea of cross multiplication, at the end of the day, if you make x the subject, you realize that x is going to be equal to x is going to be equal to what? 200. Okay. 200,000. 200,000 centimeters. Okay. Times 1 meter all over. All over what? 100 centimeters. All over 100 centimeters. At the end of the day, you realize that centimeters is going to take care of centimeters. This centimeters will take care of this centimeters. And two zeros will also take care of what? Two zeros. These two zeros will also take care of these two zeros. So at the end of the day, we are just going to be left with x is equal to 2000. We're just going to be left with our x to be equal to 2000 meters. So finally, we can say that x is equal to 2000 meters. Okay. So since x is equal to 2000 meters, it implies that our actual distance between our actual distance, okay, our actual distance between the 2 points is 2000 meters, okay, or 2000 meters is also the same as 1 kilometers because 1000 meters makes 1 kilometers, okay. Yes, so uh you can, if you want to write your answer in kilometers, if you do the convention, you realize that, or what, two kilometers. Yes, if you convert your answer into kilo to, you are going to get two what kilometers. That is also not bad. That is also not bad. Yes. So let's quickly take our next question too and see how best we can be able to play with it to test our understanding. Okay, to test our understanding even before we come to move to the angular disclosure calculation. Okay, so our next question says that if the actual distance between 2 points is 15 kilometers and the distance on the map is 3 centimeters, what is the map scale? So first of all, what do we have to do? We only have to pull down our given. Okay, we only have to pull down our given. And with the help of the given, we can be able to solve the work. So first of all, we have to pull down the given. We have to pull down the given. Then from the given, we come and abstract the vital information from the work itself. So if the actual distance between 2 points is 15 km, so let me say actual distance, actual distance, our actual distance is 15 km. So our actual distance is equal to AC, which is equal to 15 km, 15 km, good. And the distance on the map, so I will call here map distance, map distance, map distance, which is equal to MD. So the map distance, which is the same as my MD, okay, is also equal to what? 3 centimeters. Good. What is the map scale? What is the map scale? What is the map scale? So they are looking for the map scale. They are looking for the map scale. Good. They are looking for the map scale. So from what we just learned earlier, we can just apply that to make life very, very much easier. So our map scale is what we don't know. So we just come and write our solution and see how best we can be able to travel. Okay. Please, in a very big place, I would advise you to pick a jotter so that as you watch the video, you can be able to jot down some important or vital points even before the exams to enhance your understanding. To enhance your understanding. Okay, before anything, we said that our map scale, okay, our map scale is equal to what? Our map distance over our actual distance. our map distance over our actual distance. Okay. Also, we said that the map distance is measured in either what centimeters or millimeters. Yes, it will either measure be in what centimeters or what millimeters, and the actual distance will either be in what kilometers or meters. So take note of some of these things so that you don't misarrange them. If you misarrange them, it will affect your calculations. Yes, it will affect your calculation. So your map scale now is equal to, let's go to our given. So our map distance, what is the value of our map distance? It's 3 centimeters. So we put 3 centimeters over here. Let's go and look for the value of our actual distance. They say it's 15 km. Good. So we put 15 km over here. 15 km over here. As simple as that. So the question said we should find for the map scale. Okay. Before we can be able to find for the scale, a scale is supposed to be a ratio and it has no unit. Okay, but these two guys over here, you realize that they're having a unit attached, which means that before we can be able to find for our map scale, we have to let these units cancel each other so that we can get our scale unitless. Okay, we can get our value to be unitless. But in this case, since they are all having different units, we can't cancel out. We have to find a way to make sure that they are all in the same state of mind before we can what, work on them. Okay. And in doing so, they must all possess the same units. From our conversion table we learned earlier, from our convention table we learned, or better still, I can quickly put it over here for us to see. Yes. Let me just quickly put one over here as a reference for all of us to use. Okay. So we say this is millimeters and this is our what? Centimeters. This becomes our decimeters. I can call this my meters. This becomes the decameter. Okay, good. And this is now our what? Hectometer. Yes. Let's come and calibrate the right hand side too. Let's say this is centimeters. This is decimeter. This is meter. This becomes the decameter. It's just a simple table. It's at the back of some of your exercise books. Okay. If you have a very good exercise book and you look at the back, they put in some of all this uh, measurements over there. Okay. So you just have to master them so that you don't find yourself wanting. Okay. Yes. You have to master them because in physics, measurement is a key. And without the convention, I don't know, you are going to face a lot of challenges. You are going to face a lot of challenges. Okay. Yes. So you just have to master this table so that life can be easier. Life can be easier. Try and copy it somewhere. Better still, you can take a screenshot of this and save it on your phone. You can use it as a wallpaper so that the more you see it, uh, the more it becomes used to you. Okay. Yes, the more it becomes used to you. So I call this the convention hot. It's just a convention table. Yes. So we are going to read that from the table. We are going to be using this table for all our readings. Okay. So now we want both of them to be in the same state so that we can let their units cancel out before we can be able to what? Solve for it. But we have to either choose to convert centimeters into kilometers or kilometers into centimeters. Any of them will work. Okay, any of them will work. But if that is the case, let's convert the kilometers into what? Into centimeters. Okay. In doing so, what must we know? Let's quickly move to our table and see how best we can do that. You can see that we have 10 over here. Okay. We have 10 over here. So this 10, if it multiply 10 times 10, what will you get? Use it to multiply this 10 again, times another 10, times another 10. And what are you going to get? Let's all try that together. 10 times 10 times another 10 times another 10 times another 10. You see that you are going to get what? 100,000. Okay, which implies that 100,000 centimeters is equal to what? 1 kilometers. Okay, yes. So that is what the rule says. Okay, so we say that if comma 100,000, okay, if 100,000 centimeters is equal to 1 kilometers, is equal to 1 kilometers, then comma, it means that our 15 km, our 15 km is equal to what? X centimeters. Okay, our 15 km is equal to what? X centimeters. So from here, the rest is no more um physics. The rest becomes mathematics. Okay, so you just have to make X the subject, and then life becomes much more easier. Let's all do that together. So in by transposition of formulas, this will multiply this. This will also come and multiply this. Yes, as we are seeing over there. They will multiply each other. Cross multiplication will happen over here. Okay. So from that, you realize that X is going to be equal to what? 15 km. Okay. 15 km times 100,000 centimeters. Okay. All over what? 1 km. All over 1 km. At the end of the day, how do you realize? Km will cancel km. This km will cancel km. Okay, so finally we can say that our x, our x is equal to what? 15, or our x is equal to what? Or centimeters. Okay, yes. So from here, we see that they are all now in the same unit. So we just quickly write that down and then let the units cancel out and then get our scale, and then we are done for the work. Okay. So now that we know that x is equal to this value, finally we can say that what? Our map scale, our map scale is equal to what? Um, 3 centimeters over 15 km. Look at it. Initially it was what? 3 centimeters all over what? the 15 what km now is equal to what? 3 centimeters all over what? 1500. Okay, all they are all in centimeters this time. Okay, and they are all in centimeters this time. So it's just a matter of letting the units cancel out. Okay, this will take care of this centimeters will take care of this centimeters. Centimeters will take care of centimeters. And at the end of the day, you realize that you are going to get a perfect scale. Okay, so the 3, it can go into uh, the denominator. Okay, and at the end of the day, let's say that have a look at something. 3 will go into itself one time and go over here how many times? Okay, so at the end of the day, better still, you could also point that into the calculator, and then you realize that uh, life is going to be much more easier. Okay, life is going to be much more easier. So you are going to be getting 1 over 500,000. Okay, after punching that into the calculator, you're going to be getting 1 over 500,000. Okay, 1 over 500,000. And that is going to be the value of our scale. That is going to be the value of our scale. And that is going to be the value of our scale. That is going to be the value of our scale. Okay, good. So let's quickly pick a different question too and see how best we can be able to play with it. Let's quickly pick a different question and see how best we can be able to play with it. Okay. So let's try this question. Let's try this question. And the question says that the sum of internal angle, the sum of internal angle of a 7-sided plot of land is 88 degrees, 33 minutes, 56 seconds. What is the magnitude and sign of angular misclosure? Also, what correction should be applied to each angle? Okay. When you meet such a question like this, first of all, we said that the first thing we are supposed to do is we are supposed to put down our given. Yes. First of all, we are supposed to put down our given. And after putting down the given, this is what we are going to do. But even before we solve this question, this is an angular misclosure question. Okay. Yes. Even before we solve this question, let's go and solve one last more question on the scale so that we know that we are done with the scale. When we come, we'll just come and treat this and then we wrap up. Okay. Yes. And then we wrap up. So let's all try that together. So this is the question. Okay. The question is saying that we should convert 1 inch into 20 feet. Convert 1 inch is equal to 20 feet into what? Equivalent scale. So if you are being asked to convert or solve such a way, how do we go about Okay, how do we go about it? So we can move for this one, we can just move straight forward into our solution. Okay, and because we learned previously that our scale is equal to the map distance over the ground distance. We could just quickly use that to what represent it. Okay, we learned that our map scale is equal to the map distance all over the ground distance. Okay, or even better still too, it could be the actual distance. Okay, in this question you can see that they are not using millimeters and centimeters, or they are using inches and feet. Okay, so it implies that the approach or the technique we have to adapt in this case too has to be a bit dynamic from the other ones. So our map scale, as we have been given in the question, we just have to write it in that form. Okay, so this is 1 is to what? 20. Okay, yes. And we realize that this one was also in inches. Okay, so just as we did for the initial one, we have to do the same thing for this one too. Okay, we have to be able to do the same thing for this one too. So we have to either choose to convert the inches into feet or feet into what inches, so that they'll all be in the same unit, and we can let them cancel out so that life can be much more easier. Okay, yes. But you realize that from the handouts or the slides that were given to us, one of them stated that 1 foot is equal to what? 12 inches. Yes, 1 foot is equal to 12 inches. But, so let's say but what? 12 foot is equal to, or let me say 1 foot, okay, but 1 foot is equal to what? 12 inches. 12 inches. Even if you take a tape measure, you see it on it. Yes, it's equal to 12 inches. It's equal to what? 12 inches. So which one do we convert? Let's convert the 1 inches into feet too. Okay. Let's convert the 1 inch into feet. So we say that uh but what? 1 inch is equal to what? X. Okay, so let's put the 1 inch over here. Let's put the 1 inch over here. So it implies that we have to make S the subject. Okay. So if that is the case, from transposition of or from cross multiplication, we're going to realize that our X is now going to become what? Um 1 inch. Okay. The 1 inches times 1 foot all over what? All over 12 inches. All over 12 inches. Okay, at the end of the day, inches will cancel inches. Inches will cancel inches. So what are we left with? We are left with 12. We are left with 1 over what? 1 over 12. And what does uh, 1 over 12 implies? What does 1 over 12 implies? Better still to, if you like to, we can convert the 20 feet into inches. Okay. If let's also try that approach and see how it will work. If you also want use that method to, it is also quite accepted and also quite appreciable. So to also do that, we have to just turn around. Okay. So let's also see how we can convert the 20 foot, the 20 foot into inches. So if you want to also do that, we will intentionally put x over here. Okay. We will intentionally come and put x over here. So if you put x over here, you just have to make x to the subject. So in doing so, what is x going to become? You realize that your x is going to now be equal to 20 foot. Okay. 20 foot times 12 inches. 20 foot times 12 inches. All over 1 foot. All over 1 foot. Okay. So from here, what do we do? From here, what do we do next? We just have to let uh, foot cancel foot. Okay. So from there, we multiply the 20 times the 12. And 20 times 12, what is that going to give? It's going to give you 240. Okay. So you realize that the value of our x, the value of our x is going to become 240, 240 inches. Okay. 240 inches. Yes. So initially we knew that our map scale was equal to this. Initially we knew that our map scale was equal to this value. But because we wanted them to be in the same unit so that we can be able to cancel out, that is why we have to come and convert the 20 feet into what? Inches. And in doing that, this is what we had. So let's go and write our original equation, then we see how we can fix it back into it to make life easier. Okay. So we said that first for 4, we said that our map scale, which is our map scale, was equal to 1 inch over 20 feet. 1 inch inches over what? 20 feet. So we came to convert the 20 what feet into what inches. And at the end of the day, finally, we later had what? 1 inch. 1 inch is to what? 240. Okay, it's the 240 inches. So from here, you realize that life has become much more easier. Okay, which implies that we can let the inches cancel inches. And we can now say that our map scale finally is equal to 1 is to 240. Then we are done. Okay, so we can say that therefore, that is our final answer. Our map scale, our map scale is equal to 1 is to 240. Okay. Or better still, we can also say that our map scale is equal to what? 1 over what? 240. But because the question said that we should leave the answer in the form of a ratio, we don't have to leave it in the form of a fraction. Okay. So we say that 1 is to what? 240. 1 is to 240. 1 is to 240. So you have to leave your answer in the form of a ratio. Since the question said that you should leave your answer in the form of a question. Let's quickly move to our page 11 and then see how best we can be able to accomplish this task. See how best we can be able to accomplish this task. Okay. So the question says that this is the question 3. The sum of the internal angle of a seven-sided plot of land is 88 degrees, 33 minutes, 56 seconds. What is the magnitude and sign of angular misclosure? And also, what correction should be applied? What correction should be applied to each angle? So it is as simple as that. Okay, so first of all, our number of sides is 7. That is a given. In the given, let's report some of the data. Number of sides. So number of sides. And the number of sides is 7. Number of sides is equal to 7. What else did he give? So he also gave a measured sum. And this is the measured sum. This is the sum that he measured. And the measured sum, let me denote it over here. The measured sum. The measured sum, which I'm going to call is equal to what? Sn. Ms rather. Okay. Ms is equal to 8, 8, 8, 9 degrees, 8, 8, 9 degrees, 33 minutes, 33 minutes, 56 seconds. Okay, 56 seconds. So I can say that this is our given. Okay, that is what they gave us. And they are saying that we should find the what? We should find the magnitude and sign of angular misclosure. So let's quickly move to our solution and see how best we can use that to solve our problem. Okay, so this is our solution. This is our solution. First of all, they say we should what? Calculate the magnitude and sign of angular misclosure. But before then, we have to know the formula for our angular misclosure. Okay. And our angular misclosure. Our angular misclosure. We can say it's equal to what? The theoretical sum minus the what? Measured sum. Yes, the theoretical sum minus the measured sum. So let's call it the theoretical sum. The theoretical sum. Theoretical sum. Theoretical sum minus the what? Measured sum. Minus the measured sum. So from that idea, minus the measured sum. Angular misclosure is equal to theoretical sum minus the measured sum minus the measured sum. Okay, so from that idea, we can now say that uh, for the measured sum, it is known. This is it over here. But for the theoretical sum is what is not known and is what we have to look for to be able to what come and put it into the equation to be able to solve. Okay, so but before that, we have to know our theoretical sum. And our theoretical sum, to get that, let's denote this as our theoretical what? Sum. Okay, yes, it's equal to what? N minus what? 2. Okay, times what? 180. Where N is equal to what? The number of sides. Yes, the number of sides given in the question. Where S is equal to the number of sides given in the question. So we can now say that our theoretical sum is equal to what? 7 minus 2. Okay, 7 minus 2 times 180. And it's not just 180, it's having a decrease. So it's 180 degrees. Okay, 180 degrees. So from here, we can now say that we are going to get 5. We are going to get 5 times 180 degrees. 5 times 180 degrees is going to lead us, or is going to make an answer, or we are now going to be getting our theoretical sum. Our theoretical sum is going to lead us to get our theoretical sum to be equal to 900. Into brackets 2 dot s to be equal to what? 900. Okay, 900 degrees hot. And take note that this 900 that you are seeing over here, it is not standing alone. Okay, but in the physics world, it is having a 0 hot, minutes, and 0 seconds attached. Yes, but it's just that you can't see it. Okay, you can't see it. So, but you can choose to add it. You can choose to also ignore it. Okay, but if it is also added, it tells the examiner that at least you really understand what you are doing. Okay, you really understand what you are doing. Okay, so from there, we can now say that we just substitute our values into um, our angular misclosure, and then we are good to go. Okay, so we say that the angular misclosure, we say that the angular misclosure, the angular misclosure is equal to the theoretical sum. Okay, the theoretical sum minus the measured sum. So we just calculated for our uh, theoretical angle, and we had 900. Okay, we had 900 degrees. Okay, and I told you that 900 degrees you are seeing is not standing alone. It is in the physics world, it is actually having a what? A 0 minute or 0 seconds attached to it. Okay, yes. Minus what? The measured sum. Okay, and the measured sum was 88,889 degrees, 33, 8889 degrees, 33 minutes, 56 seconds. So let's also write that down. 889 degrees, 33 seconds, 33 minutes, 56 seconds. Okay. So from here, if you do the subtraction, if you quickly do the subtraction, you realize that you're going to get your angular misclosure to be equal to this. Okay, so you just have to just quickly do this subtraction, and then you realize that life will be much more easier. Okay, if this will confuse you too, I can just quickly take that off so that you don't find yourself wanting. Okay, you don't find yourself wanting. Okay, yes. So if you point this on a calculator, at the end of the day, you realize that you are going to be getting 0. Let's all try this together. Okay, let's all try this together. Better still, I can also come and choose to put this over here to show you something. Okay, and this that you are seeing over here is the same as this. Have a look at something. This that you are seeing over here is the same as this. It's just like 900 degrees. Okay, 0 minutes, 0 seconds. Okay, minus what? Minus 889 degrees, 33 minutes, 50 what? 6 seconds. Okay, so if you do the subtraction, you can even choose to do it this way. Okay. You borrow one from here and come and add to this, and then life becomes much more easier. Okay, but if you also know how to punch it on the calculator, why not? If you also know how to punch it on the calculator, you can also just quickly do that, and life becomes much more easier. So let's all do that together. uh 99 degrees, 0 minutes, 0 seconds, minus 889 degrees, 33 minutes, 56 seconds. And at the end of the day, you realize that you're going to get, after punching this on the calculator, you're going to get 10 degrees, 26 minutes, 4 seconds. Okay, if you are able to punch this on the calculator very well, this is the answer you're going to get. You're going to get 10 degrees. You're going to get 10 degrees, 26 uh, minutes, 4 seconds. 4 seconds. So now we can say that the magnitude for angular misclosure is what? Uh, positive 10 degrees, 24 minutes, 26 minutes, 4 seconds. Okay. The sign is positive since the angle is less than, since the sign is positive, since the measured angle is less than expected. Okay. So we need to add to correct. We need to add to correct. Okay. So I'll quickly take this off so that we see how best we can be able to move. Okay. So finally, we can say that uh, can say that our angular misclosure is what? It's positive. Positive 10 degrees. Positive 10 degrees. 26 minutes, 4 seconds. Since the measured angle is less than the expected, okay, we need to add to correct. Okay. Okay. So we have to come and calculate the second aspect of the equation. The first one we just calculated is the I. Let me quickly denote that. It is the I we just calculated for. Okay. So this time we are coming to work for II. We are coming to work for II. So they say we should, what correction should be applied to each angle? What correction should be applied to each angle? So the correction that is supposed to be applied to each angle also has a formula. Okay, and we can say that the correction should be equal to our angular misclosure over the number of sides. Okay, so the angular misclosure over the number of sides. So from there, what does that imply? We just have to substitute. It's just a matter of substitution. Okay, it's just a matter of substitution. So we can now say that our correction is equal to, for the angular misclosure, what was the value we had? The value we had for the angular misclosure was 0, or let me say was what? 10 degrees, 26 minutes, 4 seconds. Okay, all divided by 7, since the number of side is 7. So if you all quickly punch this on your calculator, you have to punch it like this. Okay, you have to punch. There is a certain symbol on the calculator like this. That symbol, it has what? B written on it like this, and an arrow moving like this in this form. Okay, inside of it, you can see something like this: degrees, minutes, and what? Seconds. That's what you're supposed to use. So if you press 10, you press this symbol. If you press 26, you have to click this symbol. If you press 4, you have to click this again. Then at the end of the day, you press your division sign. Better still, you can press your division sign. And if you press 10, you press that key. If you press 26, you press this same key again. Okay, if you press 4, you press that same key again. You move cursor down and you press 7. When you press equal to, you realize that you're going to get 1 point. You're going to get 1.490 something, 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 something. Okay. Once you get that answer, you're supposed to press shift. Okay, and press this same key again. If you press shift and press this same key again, uh, life is going to be much more easier. Okay, life is going to be much more easier, and you're going to get 1 degrees, 29 minutes, 26.29 seconds. That is going to be your final answer. Okay, but for the sake of some of us, let's work systematically so that at least some of us too don't find ourselves in problem. Okay, we're going to get 1.4906 3, 4, 9, 2, 1. You're going to get this value. Okay. So after this, you are supposed to what? Press shift. Okay. You're supposed to press shift. After getting this value, you're supposed to press shift. Okay, you're supposed to press shift on your calculator. And when you press shift on your calculator, you will go and press this key again. Okay. You go and press this key again. Then that is going to help you to get your answer in an angular misclosure form. Okay. That is the easiest way you can ever do that. If you don't know how to do that, let someone teach you so that in the exam hall you don't find yourself wanting. Okay. You press shift plus this key. Yes, so that you can get your answer in the correct state that is supposed to be in. You press this key. Okay. Then at the end of the day, you realize that you're going to get your answer in what? 1 degrees, 29 minutes, 26.29 seconds. Okay. And that is going to be the answer for our what? Or let me say that is going to be the correction. That is going to be the correction. That's that is going to be the correction. Okay. So finally, you realize that we can say that we are done. Okay. But you have to take this. You have to master this. You have to master this. You have to master this very well. If you don't understand or you don't have to you don't know how to use the calculator to get that, try to find someone to teach you, to help you how to use the calculator to solve angular misclosure questions, because it will come in the exams. Okay. So that you don't find yourself wanted. Okay. Please, and a very big please, so that you don't find yourself wanted. Okay. This, it has an arrow like this on top of it. Okay. And you also see B written on it. That key. Yes. Any number you press, you activate it, and that will help you activate all these things. Okay. So this is how to go about it. Let's quickly go back to our question one more last time again. The sum of internal angle of a seven-sided plot of land is 889 degrees, 33 minutes, 56 seconds. What is the magnitude and sign of angular misclosure? We have already done that. And it says what correction should be applied. What correction should be applied to each angle? What correction should be applied to each angle? After our calculation, we realized that we said that our correction is equal to angular misclosure over the number of sides, whereby we divided the angular misclosure by 7. At the end of the day, we had what? 1.4906. We had this answer. So at the end of the day, we have to press shift and press this key again to come and give us our correction in this form. Okay. So each angle is supposed to be corrected by 1 degrees, 29 minutes, 26.29 seconds. Okay. Yes. So we can say that this is our final answer. All right. Don't forget to see me in groups, in person, one-on-one, in case you find or face any challenges. Better still, see some of your colleagues so that they can take you through some of the critical and vital areas of the course even before the exams, to aid your understanding for your own good. Okay, for your own good.
for your own good. I will do all to meet you one last time before we meet for the exams so that at least life can be much more easier. Thank you very much for your time. May God richly bless you also. Bye bye.